Hi, this is Jeff from the Ozark Mountains in Missouri, USA. Well, what we have on tap today is a Commodore Pong console. I didn't even know they made these. A friend of mine named Bill asked me to take a look at this. It seems like he was in the middle of doing a composite output mod and accidentally dropped something on the board, and it no longer worked after that. So we'll take a look at it. Hopefully it's something simple. Now, all I could find out about these online is that they contain a Commodore chipset, made by MOS Technologies. So, don't know what we'll find inside. Let's have a peek and see if it's something we can fix. Thanks to PCBWay for sponsoring this video. They not only do PCBs and flex PCBs, they also have 3D printing service, injection molding service. They do CNC machining, sheet metal fabrication. They also have a thriving maker community where you can share projects and check out what other people are doing. For your next project, head on over to PCBWay. Okay, here is our console. And what is this, English and German? Somebody correct me if I'm wrong about that, which I probably am. But Rückstellung kind of sounds like German. Probably not pronounced like that. So we have tennis, soccer, squash, and some type of shooting. I think you can plug a couple extra controllers in here for a 4-player. Here we have a 9-volt AC, 2 connectors marked rifle. This must have been where the RF modulator was. That's probably the channel switch. This is where the cable needs to go for the composite out. And we have a battery compartment, which takes 6 AA batteries. Those look like AA's. So it should also be 9 volts. So let's pop this guy apart and see what we see inside. Now that these 2 controllers are wired in. I'm hoping this is just something, power supply related and not something in the custom chips. Yeah, this is patented in Japan and the United States. Made in Korea. This would have come out sometime in the mid-70s. So probably before Commodore put out PET. Okay. There we go. We can do that like that. And this must be the composite output. Oh, I see. The RF modulator is mounted here. Those are the same as the cover screws, I guess. Yeah, it's just not connected anymore. So it must have had the cable connected to here and run out, and the wires from the board to here. So it had power over the RF signal. Then added in modulator. So some kind of a non-destructive modification then. Okay. And our board, maybe 5 screws in total, or maybe just 4. Okay. So, yellow jack, on the right, black on the left. Power jack here. Now it's interesting, they have the wires from the battery running directly over to the jack here. But it's switched here on the positive side, but the sticker says 9 volts AC, so I wonder if we do have a rectifier here on the board. Wonder if we can get these guys loose. The rifle connectors. I don't know if I've had any piece of electronic equipment before that had a rifle connector. Okay. Got some black fuzzy stuff from a switch. I think Bill may have replaced these two switches. Here is the connector for the control. So this is a MOS MPS. This is a MOS MPS 7601. I'm not even freaking recording. Oh, I am recording. Huh. I gotta get the old man glasses out here. This is CMOS chip 4081. This is a 4069, 4019 Jelly Bean Logic. This side here we have a filter cap, a couple diodes. So perhaps it's half-wave rectified. So ground's going in here, positive is going in here. So it goes through that switch, out of the switch maybe to here. And it goes right in the cap. So this can't be an AC input, it's got to be DC. Because there's no rectifier before the cap. Well, that's interesting. Where's that sticker at? Right there. AC 9-volt adapter. It definitely says AC. But this definitely cannot be AC. There's a resistor there. A jumper link there, which goes over to a couple diodes. So maybe those are the rectifiers. It's a strange arrangement, though. Okay. So one is this way, which makes sense because we're connecting the common of the switch to the incoming power. And then the other direction, we're connecting the common of the switch to ground. So we're going to bleed off any charge that was on the cap. Some scratch marks here, but nothing that looks like it goes all the way through a trace. Probably not a hot enough soldering iron for these switches. This one's got a cold solder joint. So turn that switch on from underneath. I would expect the input impedance to be way less than 22 megohms. Switch contacts are okay. $5K, that's more like it. $40K. Okay. Guess we'll flip that like that. We'll put our meter on voltage. And we should be able to measure here to the CMOS chips to see if we have a voltage. At this point, I wasted 5 minutes or more trying to measure the power input at the board, and it turned out to be it was a silly mistake on my part, and you'll see in the next clip that I moved the leads up to the external power input jack and went on with testing. Moral of the story is, if something goofy seems to be happening, I always stop and wonder what the heck I'm doing wrong. Most of the time, in my experience, that people get on, kind of a one-way track. They're thinking one way, and it's hard to stop and get off that and figure out what you've done wrong. And most of the time, I find out it's just something silly that I've done. So don't barge ahead and start ripping stuff apart. Just stop and think about it a little bit, or go do something else for a while. Okay, move the power connections up here. There's something up with the wires coming from the battery box. I notice the negative lead here is kind of melted as well. This lead down to the speaker was. I raised the power supply to 8 volts to be closer to the rating. There's 8 volts there. Throw the power switch, and at the main filter cap we have 8 volts. It says -8 because I got my leads backwards. But if I test on one of the CMOS chips, there's nothing. So we have a power supply issue. And the power supply says it's drawing no current. So it's got to be something in this area that's like a voltage regulator, current limiter, or something like that. So we'll have a look at that next. Right here is a transistor. It's marked F, B on the top, and then 8050. I think that's an NPN transistor, a 2SB 8050, similar to a 2N3904, but higher current. And it was measuring odds. I took it out and put it on the component tester, and it looked like 2 diodes, but it wasn't showing any gain. It's kind of funny. And what happens here is that our positive voltage comes in. It goes across this jumper here and into the collector of this transistor. There is like a 1 watt 330 ohm resistor here to the base, and I think this lets the base charge up and then turn on, and then we have our voltage over here minus whatever the drop through the transistor is. There's a couple of small signal diodes in here, which might be some reverse polarity protection. Maybe if it's AC, it couples the other half of the AC. I don't know. I've never seen a circuit exactly like this. So my suspicion is that this transistor was not switching on like it should. It got damaged when the metallic thing fell on the board. It shorted something out, popped that transistor. So this is a 12 ohm resistor right here that I soldered in there to bypass the transistor. I'm going to turn the power supply on, which is set at 8 volts, 100 milliamps, and input to the switch 8 volts. I'm going to turn the power on. Now listen real close. Haha. So we don't have video output because the wires are disconnected, but we have a beep and we've got voltage toward the thing. We've got a beeping speaker. So the problem is we need a transistor. It is drawing right at 100 milliamps. So I'll have to find an NPN transistor that will handle that sort of current and pop it in there to see if that will allow it to turn on. So I traced out the power supply section of the circuit. We've got our 9 volts DC coming in. It's going through the switch, our filter capacitor, the collector of the transistor we talked about, the 330 ohm resistor. The base of the transistor goes to a diode, which is a W071 7.1 volt Zener, and then there is a silicon diode behind that. So this is providing, let's say, a 7.7 volt reference on the base of the transistor. So it's enough to turn it on, keep it running. And with an 8 volt input, I had about a 7.5 volt output. So I don't know if this transistor is a 2SB8050 or an S8050, but it was an NPN transistor, probably 800 milliamp IC, maximum collector current, that type of thing. It didn't seem like anything that was really that critical. So I looked through my selection of transistors and I found that I had a 2N222A, which was in a metal can. And from the bottom, the pinout looked like this. When I turned it over, the pinout looked like this. So all I had to do was kind of squash all the leads into a line to match the original transistor. And popped it into the circuit right here in place of the original, and it works fine. Everything powers up like it should. Oh, there's one of those switch covers. And so then we can move on to, when I say it powers up, it beeps. So that's a good sign. Don't know if we have video yet. Over here was our video output that was kind of patched in there, just temporary like, to see what was working, what was not. The yellow is the ground. I'm going to get the meter in here, turn it on, we'll turn our power supply on. Okay, we heard it beeping. And if I measure across the video output, you can see we've got about 3 volts. Why do we have 3 volts there? Well, the video signal itself is only around a volt. That means we have a DC offset to the video signal that we need to get rid of. Some TVs and monitors might block that, some might not. By the specification, we shouldn't have it. So what we can do is put a capacitor in series with the output, not from the output to ground, but in series. So on the positive side, we'll have our video output signal like this, and then this will go out to the output itself. And this will the capacitor will charge up to that nominal DC voltage that's floating on and only let the AC video signal through. See this a lot of time in like audio signals too. So as you can see, this thing's beeping away, so it's running, doing something, and the owner sent the original cable that was used for the RF. It's got an RCA plug on it. It's a 75 ohm cable, which is the same as for composite video, so that'll do the job. Need to figure out how to mount this in here and get the capacitor in there and secured and that type of thing. And the one other thing I think we might want to take care of before we put this all back together is this faceplate has come unglued, and we got to unscrew these 2 dealy bobs. That's for the extra controllers, and let this fall out and stick it back on there somehow. Well, I took our 2 jacks out of there. I think we can just push that loose like that now. And yeah, the glue they had on there just gave up the ghost, didn't it? So, I'm not sure how well that'll clean off there. I'll try it, and then I think we'll use some of that 3M double-sided sticky tape. You've seen me use a lot of times. It's real thin. I use it for gluing rubber feet back on, that type of thing. It works really good. So I'll go ahead and do that. And oh, interesting. There's some extra hole right there that was crudely broken off. Huh. Anyhow, I'll get this fixed up, and then we'll worry about the video. Okay, got out the 3M Scotch double-sided tape. Catalog number 136. It's great stuff. And you might just be able to see there, it's kind of hard to see, but I've got it, you know, all over the back. And it has to go on there. Kind of like that there. I did wipe everything down with alcohol. It didn't really take the old glue off, but it got rid of the crusty, crumbly bits. So, there we go. Now that's not loose anymore. I'll go ahead and clean this up and put those jacks back in there, and we'll worry about that video. Okay, so here's the signal on the scope loaded. 200 millivolts for division, so we're about 600 peaking to 800 millivolts, so it's fine when it's loaded. There is a DC blocking cap in here, right here, across these two joints. It's on the other side of the board, so it won't flip over now since it's on. And I got out this $12 thrift store monitor because it has a composite input, which works very nicely with this signal. I think that's not too bad for the mid-1970s. It beeps and boops, and it's, you know, tennis or Pong or whatever you want to call it. So I guess the only thing left is to go ahead and hook up the actual cable instead of this jerry-rig thing I have here. And I thought maybe I would need a resistor in series to tone the voltage level down, but nope, it's just fine once it's loaded. So we are good to go to solder on the cable and put it back together. Okay, I've just about got it reassembled, got all the jacks in there and the board in. You might remember there's a couple wires that looked melted or something. I think they just got squashed under the board. I can understand that because getting all these wires out of the way where you're trying to put the board in is a real pain. The original RF modulator is bolted back in place but not hooked up. And you might just be able to see here, there's a zip tie right there. I pushed the cable back through a little bit to create a little slack, put a zip tie on there so it acts as strainer leaf. So when the cable's being pulled, it's being pulled against this strainer leaf, not where it's soldered to the board. And then I soldered the wires back to the battery holder. And in the beginning of the video, when I was having such a problem measuring the voltage, just because I had my test leads clipped on here, not thinking that these two sections is a joining piece, as is these two sections, and right here is where I should have hooked. Anytime something crazy seems like it's going wrong, I always suspect myself because, you know, everybody gets in kind of a one-track state of mind, and you just got to stop and maybe do something else, or, you know, chill out a little bit and you'll figure it out. Okay, I'm going to finish putting this back together and we'll play some Commodore Pong. Okay, different camera angle, trying to get this little monitor and everything in the shot. Got it all back together. Got some power hooked up temporarily to the external power input, which is 9 volts DC, center positive, by the way. Right now we're on tennis. It has a blue background. If we put it on soccer, it looks the same with a green background. Squash looks the same with a red background. And the rifle, black background. I think if we put it on no, I don't know how we do the 4-player thing. I think we don't have the other controls marked in there, and I can do the paddles like that. Both are set on amateur. And if we press serve, what happens? There goes the ball. There's some vertical banding. I don't know if it's coming across on the camera. What happened to the... Oh, now it's showing up. Okay, yeah. Well, that's kind of weird, isn't it? I wonder if this switch is supposed to do... I don't think that's right. Huh. Oh, press reset. Okay. I see. When you change the game, you have to press reset. So it gets there. Okay, that makes sense now. Okay, so if we go back to tennis and press reset. Okay, go to soccer, press reset. Well, this is very confusing to do by yourself. Gah! It's like being schizophrenic and playing a video game. You don't know who you are or what you're doing. Okay. I think this is squash, handball, I don't know. Reset. Okay. There we go. Now we got some English on it. Okay. Reset. And yeah, we don't have the rifle controller thing, so that's not going to do anything. Okay. So I guess we're working right now. And option 4. Okay, 2 is for 2-player, 4 for 4-player. What happens if we put it on expert mode? Not sure what the difference between normal and expert is. Size of the paddle, maybe? Okay. Put them both back on amateur. Well, I don't see anything. I'm not sure about that. So Well, this has been kind of a fun little project. I didn't even know Commodore made a Pong type machine, and I was really surprised to find out they made their own chip rather than using the GB Instruments. I think that was the name of the company that made them, that made all the chips that were used in, by just about everybody else that made a Pong console, except Atari. And no, this is not a copy of Atari. Atari actually copied Pong from Magnafox. Anyhow, this was fun. Thanks for Bill for sending this in. Oh, you notice it's quieter now. I did actually find the power supply I used with this monitor when I first tested it. So I'm on the lookout for the proper power supply for it. And Bill, I'll get this on its way back to you. It was a lot of fun to work on. And until next time, bye.